We are going to look at how mixed numbers and improper fractions are the same and different. So let's look at these words first. What is a mixed number and what is an improper fraction? Let's do a word inquiry. What does mixed mean and what does improper mean? And how does this connect to mathematics with numbers and fractions? Pause the video and talk about what these words mean. Okay, a mixed number is mixed because it has two types of numbers in it. It has a whole number, such as 3 or 1 or 2. This is a whole number. And it also has a fraction, such as 1/2, 2/3, or 5/6. This is a fraction. It's called a mixed number because it combines a whole number and a fraction together, such as 3 and 1/2, or 1 and 2/3. An improper fraction, maybe you talked about how im means not, and proper, what is something when it's very proper? It's correct. It's the right way. Well, an improper fraction is not considered the correct or right way because a mixed number is considered the correct or right way. But improper fractions are part of our math world. And so an improper fraction might be 5/4 or 7/3. What is improper? Not correct or right. You may have noticed that the numerator is larger than the denominator. And when this happens, we consider it improper. It's not correct. Correct would be to say 3½ is kind of the proper way, but we still use improper fractions in our lives. Today we're going to look at the mixed number 1 and 2/3 and the improper fraction 5/3. These are equal, they are the same. Today we have to prove it. You're going to need more than one set of fraction tiles. You may need 2 or 3 for today's lesson and share with a partner. Using your fraction tiles, build both of these numbers and prove why they are the same. Pause the video here and give it a go. Okay, let's see what we built. If I look at 1 and 2/3, I can build it this way, 1 and 2/3. But if I want to prove that this is the same as 5/3, I may want to show that 1/2 is the same as 3/3, and we still have those 2/3, so I can show that it is 1, 2, 3, 4, 5/3. 1 and 2/3 is the same as 5/3. Now that I've built my model to show 1 and 2/3 is equal to 5/3, I now want to draw my model. How would you draw this as a tape diagram, and how would you draw it as a number line? Pause the video and give it a go. Okay, let's talk about it. In my tape diagram, I have 2 holes because I'm doing more than one. So I need to now, since this represents 1 hole and 2 holes, I now need to think how to partition this or put it in parts of thirds. So I'm going to have to estimate, or you may be using grid paper to make it even more accurate. And when I look at this, I can say this is 1/3, this is 1/3, and so on. They're each worth 1/3. I want to label to show the amount. And I might show that this is 1 and 2/3. And that that is actually equivalent also to 5/3. I might color those in, and I can even give another label on top. Maybe I want to even erase my 1 and 2, and I want to show that this is the same as, I'm gonna run out of room here, but you hopefully didn't, 5/3. I'm showing that these are equal. I also could have done it by drawing 2 tape diagrams and comparing them. That's another approach. Let's look at the number line. Just like my tape diagram, I have to partition it into parts. In this case, I have 0 to 1 and 1 to 2. And again, I'm partitioning into thirds. So this would be 1/3, 2/3, 3/3, and I do want to label that 1 as 3/3 because we're talking about mixed numbers and improper fractions. 4/3, 5/3, and what would 2 be? It would be 6/3. And just like I did before, I would want to show that 1 and 2/3 is here, and that is the same as 5/3. So I might even circle this to show that they are equivalent.